Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So if I subtract 10 on both sides, these two cancel out, and I get x to the power of 3 plus x minus 10 is equal to 0. Now, from here, to actually find all of the solutions for this equation, we have to first start by finding one solution and then use that one solution to find the rest. So how are we going to find that one solution? Well, we're going to simply have to guess. So let's start with x equals 1. When x equals 1, I get 1 to the power of 3 plus 1 minus 10, and this is equal to negative 8, which does not equal 0, which is wrong. Now let's try x equals 2. When x equals 2, I get 2 to the power of 3 plus 2 minus 10. 2 to the power of 3 is 8, 8 plus 2 is 10, 10 minus 10 is 0, so this works. So now that we have one solution of x, we can use this solution to find out the rest of the solutions. And how are we going to do that? Well, if x equals 2, this means that x minus 2 is a factor of our original equation, because if we plug in 2 for x minus 2, that equals 0. This means that I have to divide x minus 2 with x squared plus x minus 10. However, this also means what we can do is we can rewrite x to the power of 3 plus x minus 10 as, well, what's 2 squared? 2 squared is 4, so I get plus 4x, and then because we have plus 4x, what is x? What is 4x plus what is equal to x? Well, 4x minus 3x, or we could also do 5x minus 4x. So we get 5x minus 4x minus 10 is equal to 0. Now, what I'm going to do is I'm going to factor by grouping. So we can group x to the power of 3 plus 5x and negative 4x minus 10. Well, x to the power of 3 plus 5x, the greatest common factor is x. However, this won't work because x squared plus 5, that can be simplified. So what I'm going to do is rewrite this as x to the power of 3 minus 4x plus 5x minus 10 is equal to 0. So now, if I factor by grouping, the greatest common factor from x to the power of 3 minus 4x is x, so I get x times x squared minus 4, plus from 5x minus 10, the greatest common factor is 5. So I get 5 times x minus 2 is equal to 0. Now x squared minus 4, I can rewrite that as x plus 2 times x minus 2. And I have this plus 5 times x minus 2 is equal to 0. Now from here, I can factor out x minus 2, so I get x minus 2 times x plus 2 plus 5 is equal to 0. And this simplifies to x minus 2 times x squared plus 2x plus 5 is equal to 0. Now this gives me two equations. I get x minus 2 is equal to 0, and I get x squared plus 2x plus 5 is equal to 0. Well, for x minus 2 equals 0, I can simply add 2 on both sides, so I get x equals 2. And we already got the solution by guessing at the start. Now for x squared plus 2x plus 5 equals 0, I can use the quadratic formula. So in this case, I get negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c all over 2a. And this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2. And you can't take the square root of negative numbers, so there's no solution for this, meaning my only solution to this equation is x equals 2. Alright, so in this problem, I have x to the power of y minus y to the power of x is equal to 17. So, to solve this problem for my solution, I'm going to first, let me rewrite the equation right here. Now to start, just by looking at this equation, what can we infer? Well, notice how we have x to the power of y minus something is equal to 17. And 17 is greater than 0, right? Meaning, x to the power of y is greater than y to the power of x. And this also must mean that x is greater than y, and y is greater than 0. So now that we know this, I'm going to rewrite my equation here. X to the power of y minus y to the power of x is equal to 17. And x to the power of y, I can rewrite this as x to the power of y to the power of 2 over 2, because 2 over 2 is the same thing as 1, and x to the power of y to the power of 1 is the same thing as x to the power of y. Now this I can rewrite as x to the power of y over 2 to the power of 2. Because if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n, so I can switch these up. Now, y to the power of x, I can also change this up as well. So y to the power of x, I can rewrite that as y to the power of x to the power of 2 over 2. And this I can rewrite as y to the power of x over 2 to the power of 2. Now from here, remember my original equation was x to the power of y minus y to the power of x equals 17. Now I can replace x to the power of y with x to the power of y over 2 to the power of 2, and y to the power of x with y to the power of x over 2 to the power of 2. So now I get x to the power of y over 2 to the power of 2 minus y to the power of x over 2 to the power of 2 is equal to 17. Now I'm going to let x to the power of y over 2 equal to the variable a, and y to the power of x over 2 equal to the variable b. So now, if I substitute in a for x to the power of y over 2 and b for y to the power of x over 2, I get a squared minus b squared is equal to 17. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So a squared minus b squared, that's going to equal a plus b times a minus b is equal to 17. Now the only factors of 17 are 1 and 17, meaning that one of these two has to be 17 and the other one has to be 1. So just by looking at this, we can tell that a plus b is going to be 17 and a minus b is going to be 1, because a plus b is greater than a minus b. Meaning, I have two equations, a plus b equals 17 and a minus b is equal to 1. So now what I'm going to do is I'm going to add these two equations together. A plus a is 2a, b minus b is 0, so these two cancel out, and 17 plus 1 is 18. So I get 2 equals 18, and if I divide both sides by 2, I get a is equal to 9. Now I can plug back in a for 9 into my original equation. So we could just do either one. I'm going to do a plus b equals 17. If I plug in a for 9, I get 9 plus b equals 17, meaning b is equal to 8. So a equals 9, b equals 8. And we can even check it over here. Let's plug both of these in. A is 9 minus b is 8, and 9 plus 8 does equal 1. So now that we know a is 9 and b equals 8, we can go back here and notice how we let x to the power of y over 2 equal a and y to the power of x over 2 equal b. Meaning x to the power of y over 2 is equal to 9 and y to the power of x over 2 is equal to 8. So, to solve this, let's first start by solving the first equation. So x to the power of y over 2 equals 9. I can first start by taking the power of 2 on both sides. So then these two cancel out, and I get x to the power of y is equal to 81. Now 81, I can rewrite that as 3 to the power of 4. Now I'm going to do the same thing to y to the power of x over 2. I'm going to take the power of 2 on both sides, and then these two cancel out, so I get y to the power of x is equal to 64. Now 64, I can rewrite that as 4 to the power of 3. So I have x to the power of y equals 3 to the power of 4, and y to the power of x equals 4 to the power of 3. Well, what does that mean? Well, y 4 x 3, and over here y 4 x 3, meaning x is equal to 3 and y is equal to 4. So this is my solution to this equation.